Hello, my name is Johannes Kebeck and I'm a program manager in the Bing Maps team. Today I'm talking about spatial data management and visualization with Bing Maps. Spatial data is increasingly important if we look at where you want to be, where your customers are, where you sell certain products, how far and how long it is for your service engineer to reach your customers, or if you want to assess the risk for an insurance company for a certain property. Spatial data help you to get more and deeper insights and visualize them in the context of a map. In the last years, we have made a tremendous progress from spatial information and specialist tools that were handled by specialists that then transformed into more broadly available tools and websites with ever richer imagery from the air, from oblique angles, from the street side in 3D, to now the point where spatial data management and information is deeply integrated into many core line of business applications. Let me give you two examples. If we look at the Microsoft stack, you know Power BI. It's a very rich, performant, and easy to use dashboard to handle data from multiple data sources. Here we are looking at a sales and marketing sample from the Power BI dashboard. There's a lot of graphs in there, KPIs that you see. But if you drill down, then you also see that you have the sales performance per state, per market, per sales territory in there. It's just one different type of chart in the Power BI dashboard. It's part of the solution. And not only that, you can see how you can ask natural queries. You want to have the data visualized as sales revenue by state. You just type it in here in this text box, and Power BI automatically finds the right chart for you and by default shows it then as sized bubbles. You can open up the visualizations and then simply click on color-coded states, and it aggregates it up by boundaries and shows you in that way. Another example where you find spatial data management and visualization deeply integrated in Microsoft products is the Excel 3D maps. We have here a spreadsheet that shows us 911 incidents for the city of Seattle, available through their open data portal. Each of these incidents that is tracked here has already a latitude and longitude. If it wouldn't, then the tool is still able to call the Bing Map services in the backend, geocode it, and reference these information for you on the map. Now with these latitudes and longitudes, I can simply click on the 3D map, which will then open up an additional editor that allows you to style and visualize the data very much as if you would work with a PowerPoint presentation. So while the first one was more about analyzing the data in real time, here this tool is more about telling a story. So I want to look at these 5 years worth of traffic accidents, and I want to visualize where the hotspots are. I want to find out where there is the strongest need for change. So in the first scene that you see here, we have these 5 years worth of data, about 30,000 points visualized on a map. If we go a little bit deeper, then you see I can also aggregate that up by police districts that I've uploaded from a KML and shapefile. That's a technology that we also developed in Bing and then made available to the Office team. And then there's other scenes. Once you're done, then you can share this out as part of the spreadsheet, or you can even record this into a video and then publish it in your portal or wherever you would like to have it. Let's have a look at one of these videos that are created from this scene. So here is the 5 years worth of traffic accidents as points on the map. Now I had previously uploaded this police districts, and it's now re-aggregating the data based on the police districts or beat districts for the city of Seattle. The data were available as a S3 shapefile, and I uploaded that and it was automatically read and transformed to the map. Now I want to see how these traffic accidents developed over time. So instead of simple points, I created density map. Density maps are often abused and wrongly used and represent only population density. But if we want to really have the density, the hotspots of incidents that we have, traffic accidents in this case, they are a great way to find out these hotspots. Now here we are looking at one of these spots that I had drilled into, and you see in the pop-up already there is this image from the street side. I want to find out how exactly does it look there at this location. And this is where we get the street side imagery from Bing Maps. So you see I have concatenated here in this spreadsheet information that I had before to create a URL that points to the Bing Maps. And there's essentially a standard way to call the Bing Maps for a particular location and scene. And I pass in these latitudes and longitudes as parameter in that concatenated string. Now if you click on these strings, you get directly into the Bing Map site and you see the scene in street side images. And you can imagine there is this pedestrian crossing here, there's parking there, there's multiple roads that come together. It makes sense that there's a lot more of accidents than in other parts of the city. Now, what you have seen here is that in many regards, spatial is not special. So why even talk about it? It's easy to use. I don't need to do much about it. It's like handling a spreadsheet or any other data source in BI. But sometimes there is indeed a twist to it. You might think about custom data sets that you want to upload. Your sales regions, for example. You want to perhaps visualize parcel data that represent the current owner, the tax value. You might want to look at risk areas like flood zones or hazard areas for landslides. There's a multitude and a wealth of data sets, open data sets made available by the governments and enthusiasts that pull together different geospatial data sets. The other part where it becomes tricky is when you take these custom data sets, they often come in a multitude of coordinate systems and projections. So similar as we have different numeral systems to describe numeric data types, decimal, hexadecimal, binary, there's also different projections and coordinate systems to describe geospatial information. In the example that I will show you a little bit later, I uploaded a set of data from the King County GIS portal. And all these data sets were available in the NUT83 format, the North American Datum 1983. And in order to bring them in the context of a Bing Maps, we need to transform these coordinate systems and translate it into a system that we call the World Geodetic System 1984, WGS84. All this is a little bit complex. All this is not magic. It has been handled, but it is a little bit special. It can also be that you want to do more complex spatial queries than just put a point on a map, or that you want to reference it to a county or a state. Maybe you want to find out if this property is inside the flood zone. Or maybe you want to do something and find where parcel boundaries intersect with seismic risk areas. Now, today, I'm really happy to announce that we have solved this problem for you, and we made it that simple. In the Bing Maps Developer Center, we have now integrated a component that allows you to upload two very common types of geospatial data formats, the Esri shapefile format and the KML format, the keyhole markup language. And irrespective of the coordinate system that you have in the raw data, we will transform that in a way that you can store it in these Bing spatial data services, essentially a component that allows you to upload, reference, and query any type of geospatial information. This capability is available very simple through the developer portal as well as through an API if you want to build your own user interface and applications around it or integrate it in your line of business workflow. Now, at this point, let's have a look at a quick demonstration. And I want to show you this scenario that I just described. So we're looking here at an imaginary insurance company, and you want to evaluate the risk that a certain property has. Somebody calls in and he says, I would like to have a home insurance for this property. And as an insurance company, you might want to find out what is the value of the property and what risks is it exposed to. So in that context, I want to show you first the risks that exist at this particular place here. So I've uploaded before floodplains into the Bing Spatial Data Services. I overlay this now on the map. There's a few other of risk areas, let's say the landslides. There's perhaps also seismic activity in this area that exposes a certain risk. Then we have the parcel information. This is a rich set of information that gives you information about the ownership of this particular property and the tax value that it has as well. And then finally, there may be other information that matter to you. For example, if there is a flood risk, where can these people get sandbags in case they need it? How far is that away? How far are the fire stations away in case there needs to be some pumping done, or maybe there's a fire risk also? How far is that away? So we have now overlaid a number of layers here, and I want to find out for a particular property that I've entered here already, how high is the risk that it is in one of these areas? You could say, based on all these different colors here, there seems to be a death trap, and maybe we need to have a high insurance fee for everybody. But you saw previously that in the center of the city, it is actually not the case. So let's see this property. If I call now this service, it will go back to the Bing Spatial Data Service and determine first the coordinates, the latitude and longitude of this address that I just entered, the customer who wants to have the insurance rate. And B, it will then intersect this coordinate with the flood risk area, with the planes that describe the seismic risks, as well as those that describe the landslide risk. And if I click on this, we see the response. This is the text value, so it also called out and intersected with the parcel layer here to determine what is the text value of this property. And then it says, yes, we are in a flood risk zone here. Yeah, we can see that. But it is also not in a landslide risk, and it is not in a seismic risk. So this looks very simple, and it is indeed very simple to build such an application, but it was special because we had a multitude of layers that we need to put into relationship with each other. And they were even using different coordinate systems and projections. So I needed to bring this all to the least common denominator, which in this case is the World Geodetic System 1984. So what have we seen here in the background? We have visualized 6 different layers. We analyzed the spatial relationships over a good gigabyte of data that we put together here. There were hundreds of thousands of polygons and millions of vertices that we could analyze and visualize in a fraction of a second. Ultimately, what happened was a simple REST service call that went to the Bing Spatial Data Services, gave it a clear description of the data source ID, its name and the entity name, and then I intersected it with the latitude and longitude that I retrieved back from the geocoding service that translated the address into coordinates. Now, I can filter the result further down. If I have 100 properties of a parcel and I only want to have the text value, for example, then similar to a select statement in SQL, I can also say I only want to have certain properties. I can format it in different ways, JSON for example, and then I can define a callback function that does something when we get the results. Now, also in the background, we were essentially translating these very complex polygons and the large amount of spatial data into some simple tiles that basically follow the same naming convention as we have in Bing Maps. And that allows us to be very responsive in drawing this complex data in the UI and still being able to have very quick interaction when I want to pan and zoom the map. So essentially, I uploaded through this portal the data sets, and when I call now the layer for floodplains and flood risk, for example, then the .NET handler that I have here is querying the data sets. It will determine first if it is already cached somewhere in the storage that in this case runs on Azure, and if so, if it pulls it directly from there, and if not, then it goes back to the spatial data services, retrieves the vector data, rasterizes it, and writes it back into the cache. Now, what about mobile? Everything that I have done here was written in HTML and JavaScript. So That means I can simply wrap it using a Cordova application and deploy it additionally into the stores of the respective devices. So irrespective of it is an Apple device, an Android or Windows device, this technology allows me to deploy to the web as well as to any of those. And if you are a fan of Visual Studio, then the Apache tools, the Visual Studio tools for Apache Cordova have you covered. Of course, this was only one type of visualization. There was one demo that was specifically looking at the insurance risk, pulling data out of the spatial data services and intersecting it to find out what the risk is there. We can do other things if we want to look at the example where I had the traffic accidents, 911 incidents in general. Here we are looking at a different region in San Francisco, similar open data portal where we get the police districts and we get the 911 incidents. And you see how I can represent the density maps as well as thematic maps, choropleth, very similar as what I showed you in Power BI and Excel before. So you don't have to change the tool. You can develop it all in one platform. And if you do want to do something special, then Bing Maps has you covered. With that, if you don't have a Bing Maps account yet, then go and get one for free at the Bing Maps portal. If you are interested in the code for the risk management, then you can get it on MSDN. And I also encourage you to check out Ricky Brundt's session on our brand spanking new V8 map control for web applications that has a huge number of improvements compared to the previous version. With that, thank you for your time and happy mapping.